Here I have an aluminum rod, the kind of rod we use in the lab here. Okay, there we have it. Kind of rod we use for making stands and so forth. It's 1.55 centimeters long. I can balance this rod on one finger if I choose just the right position. I can find its balancing point, and then I grab it by that balancing point. And I'll turn this way so you can see what's happening. Okay, here's the rod. I'm going to strike it on the end. Now let's see what we hear. Okay, very interesting. We can match that frequency using the frequency program. Now, do you hear that high-pitched whine? There's another vibration going on in here, and we can investigate the nature of that vibration. If I touch the end of the rod, it gets rid of both vibrations pretty effectively. If I hit the rod on the end, I get more of the high-pitched whine. If I strike the rod on the floor, now don't do this on a wooden floor if you happen to have an aluminum rod, I get a very loud sound, and if I point it at you, or point it away from you, you should be able to hear a difference. This sound is quickly damped out if I touch the end of the rod, right on the end. If I touch it on the side, it isn't damped out as quickly, leading me to believe, I don't know this for sure, but leading me to believe that it's a longitudinal pulse moving back and forth through the rod. The pulses I get when I hit the rod this way, I believe, are transverse. The rod is vibrating back and forth. Let's see if I can get into back and forth like this, whereas for the high-pitched sound, I think we're hearing the rod vibrating back and forth in this direction, the particles in the rod vibrating back and forth in this direction. You should be able to match these frequencies, and from the information you have, and from certain reasonable assumptions about the wave, you should be able to determine the speed of the transverse pulse, which is what you're hearing most of right here, and the longitudinal pulse, which you ought to be hearing very clearly here.